Friends, today we are going to describe the program of the sum of the digits of a number which have been dealt with this while loop. So while loop program already has been explained to you in the light of the factorial of a number. So now this while loop will help us to find the sum of the digits of any number supplied by the user. Suppose if user supplies the number 125. So what will be the result? What will be the expected result? 1 plus 2 plus 5. That is 3 plus 5 is equal to 8. So 8 will be the desired output. If the user, suppose the user gives the number 256, then the result will be 5 plus 2, 7 plus 6, that is 13, and so on. So our objective is to find the sum of the digits of a number, whether it is a 3-digit number, whether it is a 2-digit number, whether it is a 1-digit number, irrespective of the number of digits the user gives, we will always try to find out the value of the sum of the digits of that specified number. So suppose the user gives a very large value like this, 55,000, 65,000, 535. 65,535. So it is a fairly large number. So this 6 plus 5 plus 5 plus 3 plus 5 will, whatever will be the sum, will be printed. 6 plus 5 is 11, plus 5 16, 19, 24. So this 24 will be our answer. So for that to be dealt with, we have used the while loop construct. That is, first we have taken 3 variables, that is int n, the number, r will be just the remainder section, the remainder value, and the sum is equal to 0. Then the user will be prompted to input a number from the standard input device, that is the keyboard. Enter a number, user will supply the number n. Then we will come to the while construct, that is the logical section of the program. This is just the logical section of the program is just within this portion. So this while n greater than 0, what I mean by while n greater than 0, that is any number which is greater than 0, whose summation is to be sum of the digits is to be determined. So the number will be positive. We are assuming that the number is positive and the number is a non-zero number. A non-zero positive number, that is, it can start with 1 and go up to several higher values. It may go up to very high value but not an undefined value. It has to be a finite value starting from 1. So this, suppose the user has given 256. So let us just perform a dry run on the expression statement so as to make you understand what are the meanings of these expression statements which I have written. So suppose the user gives the n value to be 256. So n is greater than 0, definitely n is greater than 0, 256 is definitely greater than 0, so we enter the while loop. The program control enters the while loop because the condition is met. So this r is nothing but n percent 10. So since we are dealing with the decimal numbers has a radix of 10, so we will divide the number by 10 to find out a single digit of the number, that is starting from the units, tens, hundreds, thousands, 10,000s, lakhs, millions, and so on. So first we are going to divide this n number by 10. So that will yield, say suppose that will yield 256 divided by 10 will yield a remainder of how much? That is definitely 6. 6 will be stored in n. So the sum will be now, sum is equal to 0, now 0 plus r, that is 0 plus 6. That is sum will become how much? Sum will become 0 plus 6, that is 6. So it is quite clear that the sum will now hold a value of 6. Now the next statement is n is equal to n slash 10. When we divide the number 256 by 10, the number is updated to a number 25. See, because if we divide it by 10, the quotient part is nothing but 25 and the remainder part is 6. So 6 is stored in this r and the quotient part will be stored in the value, and that will become the updated value of n. So in that case we are just trimming of this 6 by this pair of operations, that is r is equal to n percent 10 and n slash 10, n is equal to n slash 10. So it will become 25 because we are dealing with integer numbers. So it will not yield something a value of 25.6 like a float value or a double value. It will always yield an integer value. So the quotient will become 25 and not 25.6. So that 25 will be stored in n to be the updated, to give the updated value of n. So now we enter the loop once again. We try to enter the loop once again. So in the next iteration we'll check whether we can enter the loop. Let us check. So 25 is definitely greater than 0. So again the program control enters the while loop for the second time. So r is equal to n percent 10, that is r is equal to 25 by 10. It will just return the remainder, that is 25 when divided by 10 will yield a quotient of how much? 2, and a remainder of how much? 5. So the 5 will go into this n in this r, and then the next statement is sum is equal to sum plus r. What is the last value of sum? We have recorded 6. So this 6 will be added to this 5 to give you the result 11, which will be now the updated value of the sum. Then comes the division operation, and that will yield the quotient to be 2. So n becomes now 2. Let us now again go for the third iteration whether we can enter the loop. Let us see. Yes, n is 2, which is definitely greater than 0, and again we perform the same operation, that is 2 is divided by 10. So if 2 is divided by 10, the quotient becomes 0 and the remainder becomes 2. So this r is equal to 2 will be stored in this r value. So r becomes 2, then sum will be again added to this new r value, that is sum is equal to now 11 plus how much? 11 plus 2, that is 13. So sum will become now 13, then n will be again updated by this operation 2 slash 10, that will yield a quotient of 0. So n will become now 0. Now we try to enter the loop for the fourth time. Let us see whether we can enter the loop. No, we cannot enter the loop. See, because n has become 0, and definitely this condition doesn't hold good because n is greater than 0 is the condition. While n greater than 0, we can enter the loop, and if n becomes 0 or it becomes less than 0 or something like that, we will not be able to enter this while loop block. Then as it is 0 now, as the n value is 0, then we don't enter this while loop. The program control just comes out of this statement to the closing brace, and after that we will return the result. We will print the result. The sum is %d sum. Whatever is the last value of sum, that is in our case it is 13. So the result will be the sum is 13. So our expected result was what? 2 plus 5 is 7 plus 6 is equal to 13. So we get the result as 13. So our program is quite correct. So it will run on your computer now. If you have any doubts or queries pertaining to this program, you can easily write in the comment section and reach us in the comment section so that I can address your queries and comments from the comment section. Thank you, friends.